We now discuss the solution of a problem from the section Linear Algebra that has appeared in CSIR National Eligibility Test held on 16th September 2022. The problem is related to determinant and a trace of a 5 by 5 invertible matrix under given conditions. The given problem is, let capital A be an invertible 5 by 5 matrix over a field F. Suppose that the characteristic polynomials of A and A inverse are the same. Which of the following is necessarily true? We are given four options. Option A, determinant of A square is equal to 1. Option 2, determinant of A power 5 is equal to 1. Option 3, the trace of A square is equal to 1. Option 4, trace of A power 5 is equal to 1. We are given capital A is an invertible 5 by 5 matrix over a field F, and it is given that the characteristic polynomials of A and A inverse are the same. Then we have to decide which one of the following is necessarily true. We now discuss the solution of the problem in detail. We are given capital A is an invertible 5 by 5 matrix over a field F. Suppose that the characteristic polynomials of A and A inverse are the same. This means A and A inverse have the same eigenvalues. Let's call them as lambda I. I is equal to 1, 2, 3, 4, 5. Note that none of these eigenvalues lambda I is 0. Why? If any one of them is 0, then the determinant of A is 0. Thereby, A will be singular. Then A is not invertible. Thus, none of the eigenvalues of values is 0. Agreed. Agreed. So now, determinant of A, and we know the eigenvalues. Then the determinant of A is equal to the product of the eigenvalues, that is lambda 1 multiplied by lambda 2, lambda 3, lambda 4, lambda 5. But lambda i's, I is equal to 1, 2, 3 up to 5 are also eigenvalues of A inverse. The product of these eigenvalues is also equal to the determinant of A inverse. We know the determinant of A inverse is 1 by determinant of A. Thus, we have determinant of A is equal to 1 by determinant of A. Cross multiplying, we will get determinant of A whole square is equal to 1. Determinant of A whole square is equal to 1. Agreed. But we want to, one of the options says determinant of A square, A square. So, further, determinant of A square is equal to determinant of A square is A into A, and we know the determinant of A into A, both are square matrices. So, that will be equal to determinant of A multiplied by determinant of A, that is determinant of A whole square. But we have just seen determinant of A whole square is equal to 1, therefore it is equal to 1. Thus, we have determinant of A square is equal to 1. Let's look at our options. So, our answer determinant of A square is equal to 1 appears against option 1. Therefore, the answer to this question is option 1, that is determinant of a square is 1. So that is the detailed discussion of the solution of the problem. Now in the next slide, I will show you that you can attack this problem by elimination process. Now the given question is here, the options are here, and we have A is an invertible 5 by 5 matrix over a field F. Now here we rule out the options 2, 3, 4 through a counterexample. So what's that example? Let A is equal to minus I5, that is 5 by 5 identity matrix minus I5. That is the 5 by 5 matrix where along the main diagonal you have minus 1, minus 1, minus 1, and elsewhere it is 0. Agreed. Now then A is invertible. Why? Because determinant of A is determinant of minus I5. Determinant of minus I5 is minus 1, minus 1, minus 1 multiplied 5 times will be minus 1, which is not equal to 0, and thereby A will be non-singular, therefore it is invertible. Because it is invertible, its inverse exists, so A inverse is equal to minus I5 inverse. Minus I5 inverse is minus I5. You can check. So minus I5 multiplied by minus I5 is identity I5 only. Therefore, and what is minus I5? It is again A. That means A and A inverse are one and the same in this case. So they have the same characteristic polynomial. Agreed. Agreed. Now A is minus I5. Square it. A square is minus I5 multiplied by minus I5 is I5. Then take its trace. Trace of A square is equal to trace of I5. So trace of I5 means the sum of the elements on the main diagonal of I5. And that is 1 plus 1 plus 1 5 times, that is equal to 5. Now, so it is 5, but in option 3 it is given 1. So by this says option 3 is not true. So also A is equal to minus I5. Now raised to the power of 5 on both sides. A power 5 is minus I5. That will imply determinant of A power 5 is equal to determinant of minus I5. Determinant of minus I5 is minus 1. That is the product of the elements that are there on the main diagonal. Minus 1, 5 times will be minus 1. And this contradicts this option 4. Option 2. Option 2. So thus option 2 is not true. And A power 5 is minus I5. Take the trace on both sides. Trace of A power 5 is equal to trace of minus I5. That is equal to minus 5. And that means the option 4 is not true. Thus options 2, 3, 4 are not valid. Therefore, determinant of A square is equal to 1. That is the detailed discussion of the solution of the problem from the section Linear Algebra. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.